Hi everyone, today we are going to learn how to multiply and divide rational expressions. Before we get started, I would like you to please go ahead and complete this warm-up where I want you to simplify each fraction without a calculator, and I want you to use prime factorization in order for you to do that. So if you notice right away in example 1 that 4 can go into 12 evenly, that's awesome, but I want you to use prime factorization as the method for simplifying these fractions. There's a reason for why I do everything, and that leads into what our lesson is all about today. So please go ahead and pause the video, and when you have an answer, please go ahead and restart the video, and we'll see how well you did. Okay. So prime factorization means that you break down each number using only prime numbers. And I know that the number 4 is 2 times 2, so I'm going to write that as 2 times 2. I know that 12 is equal to 4 times 3, so I did a little breakdown for us of prime factorization for all of our bigger numbers. I know that 12 is 4 times 3, and I know that 4 can be broken down into 2 times 2. So that is going to be 2 times 2 times 3. So what I'm going to do is I'm going to cancel out anything that's the exact same in the numerator and the denominator. So I cancel out 2 2's and I'm left with a 3 in the denominator. And whenever you're left with nothing in the numerator, we always leave a 1 there as a placeholder. So our answer is 1/3. For number 2, I know that 25 is 5 times 5 and both of those numbers are prime numbers. And I know that the number 30 is 5 times 6. And 6 can be broken down into 3 times 2. So rewriting these numbers in numerical order, I'm going to have 2 times 3 times 5. Now any number that's the same on the top and the bottom will be canceled out. So I'm going to cancel out both of my 5's and divide them out. And I'm left with 5 over 2 times 3, which is 6. So 5/6 is my answer. For 30, I've already broken that down in number 2. So that's going to be 2 times 3 times 5. And 144, that's equal to 12 times 12. So you can break it down into 2 times 6 and then 2 times 3. And then another 12 is 2 times 6 and a 2 times 3 for a total of 1, 2, 3, 4 2's and 2 3's. So that's what I'm going to write down in my denominator. 4 2's, 1, 2, 3, 4, and 2 3's, 3 times 3. Anything that's the same on the top and the bottom will be eliminated. So I have one set of 2's that are eliminated and one set of 3's that are eliminated. And my final answer is going to have a 5 in the numerator and 2 times 2 times 2, that is 8. 8 times 3 is 24. So our answer is 5 over 24. And this skill of using prime factorization in order for you to simplify fractions is exactly what we're going to be doing in our lesson today. So our learning target for today is for you to be able to say, I can simplify rational expressions. So we're going to be simplifying them by factoring and eliminating common factors from the numerator and the denominator. And I want you to also be able to say that I can simplify rational expressions in order to solve real-world problems. So we're going to actually have a real-world problem. So this first lesson is all about simplifying fractions, and our next lesson is about multiplying and dividing fractions. Now, a rational expression is considered in simplified form. So that's what our goal is, to simplify all of these fractions. It's going to be in simplified form if its numerator and the denominator have no common factors other than a 1. That 1 could be positive, that 1 could be negative, but there are no other common factors other than the number 1. So in order for you to simplify a rational expression, you'll have to follow the following property. So let's say that we have 2 numbers that are being multiplied together in their numerator, a times c, and we're dividing it by b times c. Because both of these, both the numerator and the denominator share a factor of c, we're going to divide it out and it gets canceled away. So we're dividing out the common factor of c, and what you're left with is a over b. So this expression, A, B, and C could be numbers, they could be letters, they could be expressions. But if you notice something on the numerator and the denominator that is the same, you can eliminate it. But the thing that I need you guys to know is that the main operation, this only works if the main operation in both the numerator and the denominator is multiplication. So if you have the main operation being addition or subtraction or something else, then this property will not work. You need both the numerator and the denominator to have the main operation, the main thing that's happening, being multiplication. Otherwise, do not talk to me about simplifying or eliminating. You cannot do it. And that is one of the biggest errors that students make on this test. Please do not fall into that trap. So looking at the next example, it's very similar to what we did in our warm-up today. So we had 15 divided by 65. And if you were to prime factor each one of those, 15 is equal to 3 times 5, and 65 is equal to 13 times 5. Both the numerator and the denominator have in common a 5, so we divide it out or cancel it, leaving us with our answer of 3 over 13. And there is nothing further for you to do. So most of our problems are not going to resemble numbers. Most of our problems are going to resemble polynomials, kind of piggybacking off of what we've done in terms of graphing. So what you guys are going to see is you might see a polynomial that is either factored or maybe it's not factored. But you will need to put it into factored form if it is not already in factored form. So we'll factor the numerator and factor the denominator, and anything that is the exact same. So in this case, both the numerator and the denominator share an x plus 3 in common. So yeah, do they have addition and subtraction signs in them? Yeah, they do. However, the main thing that's happening is 4 times a parenthesis. A parenthesis times a parenthesis. The main operation is multiplication. So therefore, these two parentheses can be eliminated. And therefore, our final answer is going to be 4 over x minus 5. And that is it. So that is what we're going to be doing in this lesson. We're going to be simplifying rational expressions. And it usually takes about 2 steps in order for you to do that. The first step is, like I said to you before, if it's not already in factored form, make sure that you factor both the numerator and the denominator. So in this problem, I have x squared plus 7x divided by x squared. So I notice in the numerator that x squared and 7x both have in common an x. So I'm going to factor that out. And my leftovers is an x plus 7. In my denominator, you can leave it as x squared, or you can break it apart into x times x. While we're learning this for the first time, I would recommend splitting apart any variables with an exponent into 2, or however many variables you're supposed to split it apart into. In this case, x squared, 2x's. Next step, step 2, we need to divide or cancel, you might hear. Divide out or cancel out anything that they have in common. So anything that's the same on the top and the bottom, like in this case, they both share an x in common, gets divided out, and our answer is going to be an x plus 7 divided by x. Please, please, please do not fall into the trap of saying, oh, both the numerator and the denominator both share an x, I'm going to eliminate it. No! The main operation in the numerator is not multiplication. Do not eliminate the x's. You cannot eliminate it and say that the answer is 7. And we can certainly explore that topic when I see you next time in class, but you cannot eliminate from there. This is simply going to be your answer. So hopefully I've stressed that enough. Main operation in both the numerator and the denominator has to be multiplication in order for you to eliminate. So let's look at example number 1. in example number 1, this is kind of nice. It's already in factored form for us. We don't really have to do much other than eliminate anything that you see in common. And I see an x plus 1 in both the numerator and the denominator, so I'm going to cancel out an x plus 1. What I'm left with is a 2 in the numerator and an x plus 3 in the denominator, and that is simply my answer. There is nothing further for us to do. Example 2 is not in factored form. X plus 4, there's nothing you can do about it, but x squared minus 16 is special. This is a difference of 2 squares, so we need to factor it. So I'm going to rewrite this as an x plus 4. You can put it in parentheses if you want, you don't have to. And I'm going to split this dots into an x and an x. Square root of x is an x and an x, or square root of x squared is x and x. And the square root of 16 is 4 and 4. And because there's a minus sign, we'll have a plus and a minus. In this case, the x plus 4s are located in both the numerator and the denominator, so we can cancel them out. And I'm left with an x minus 4 in the denominator. Please do not fall into the trap of simply saying that your answer is x minus 4. We still have to have a 1 in the numerator as our placeholder. So that is our answer, 1 over x minus 4. For number 3, we have to factor both the numerator and the denominator into 2 parentheses. So I'm going to factor each quadratic individually. So I have x squared minus 8x plus 16. I'm going to split apart the x squared into an x and an x. And whenever I think of 16, I always think of 4 and 4, and then I think of 8 and 2. So 4 and 4, can I get a negative 8 from 4 and 4? Why, yes, I can. I can go negative 4 plus negative 4 equals negative 8. So I have an x minus 4 and an x minus 4. In my denominator, I'm going to split apart the x squared into an x and and ask myself, what 2 numbers multiply to equal negative 24, but together add to equal positive 2? So whenever I think of the factors of 24, I always think of 4 and 6, then 3 and 8, then 2 and 12. And I know that 4 and 6 are actually 2 units away from one another. And if I want a positive 2, I'm going to need a positive 6 and a negative 4. Now, looking at both the numerator and the denominator, both the numerator and the denominator have an x minus 4 in common. So I'm going to subtract or divide that away, and I'm left with x minus 4 divided by x plus 6. Do not eliminate the x's at this step. Do not divide out a 2 between the negative 4 and the 6. The main operation is not multiplication, so therefore we leave our answer the way that it is. Let's go ahead and flip the page. For example number 4, we want to factor. So what I want you guys to please do is try examples 4, 5, and 6 on your own. Please go ahead and pause the video, try to factor each one of these individually, and then when you have an answer, I want you to go ahead and restart the video and we'll see how well you did. Okay, let's go ahead and look at example number 4. In example number 4, we have 40x plus 20. Now, both of these 2 terms have in common at least the number 20. 20 can certainly go into 40. So I'm going to divide out a 20, and my leftovers is 2x plus 1. So even though the 20 goes away, you still need to have that placeholder of the number 1. 10x and 30 both have in common a 10. So I'm going to factor out a 10, and my leftovers is an x plus 3. Now, 20 and 10 both have, 10 can go into 20 evenly, and I can divide these 2 numbers out. And I know that 20 divided by 10 is 2. So my answer is 2 times x plus 1 divided by x plus 3. Please leave your answer in factored form. So whatever your final answer is, please leave it in factored form. So leave answers in factored form. Do not distribute the 2 is essentially what I'm trying to say. So what I just wrote for you guys at the top is leave your answers in factored form. For example number 5, I'm going to split apart the numerator into 2 parentheses, and the denominator is a little bit more intense. So we'll talk about the numerator first. I'm going to split apart the x squared into an x and an x. And I'm looking at the factors of negative 15, so I have to figure out what factors of negative 15 add to equal negative 2. So whenever I think of 15, I always think of 3 and 5. And I know in order for me to get a negative 2, I need a negative 5 and a positive 3. That's my numerator. In the denominator, I have 4 terms, and we know that whenever we see 4 terms, we need to use factoring by grouping. So I'm going to put parentheses around the first 2 terms and parentheses around the last 2 terms. X cubed and 3x squared both have in common an x squared, so I'm going to factor that out, and my leftovers is an x plus 3. Plus, x and 3 do not have anything in common besides the number 1. You still need to factor out that 1 so that you have something that you've factored out of each parenthesis. So we still have an x plus 3 on the outside. So cleaning this problem up, I have an x minus 5 times x plus 3 in the numerator, and in my denominator, I'm going to have an x squared plus 1, because those are my outsiders, times an x plus 3. Now, x squared plus 1 is not a dots. It is not a difference of 2 squares. And that's because we're not subtracting these 2 perfect square numbers. We're adding them. We call that an SOS, save our ship. Sorry, you're out of luck. It doesn't work, so we're not going to factor it. But both the numerator and the denominator have in common an x plus 3. So therefore, our answer is going to be x minus 5 divided by x squared plus 1. Please do not eliminate anything. The main operation is not multiplication. We do not eliminate anything at this step. But that is simply our answer. In example 6, x to the 4th minus 81. That is a difference of 2 squares because we have an even exponent minus a perfect square. So I'm going to split it apart into 2 parentheses. The square root of x to the 4th is an x squared and an x squared. And the square root of 81 is 9, so I'm going to have a plus 9 and a minus 9. In my denominator, 3x cubed and 27x both have in common a 3x. So I'm going to factor out a 3x, and my leftovers is going to be an x squared plus 9. Now, x squared minus 9 is a dots. And we're going to need to break that down even further. So I'm going to split that apart into an x plus 3 and an x minus 3. Because remember, we want to leave our answers in factored form. So I'm going to write x squared plus 9 times an x plus 3 times an x minus 3. Do not break apart the x squared plus 9 into 2 more factors. That was a question that was actually on one of our previous tests. And a lot of kids broke that down. Please do not fall into that trap. It is not a difference of 2 squares. So I have 3x times an x squared plus 9 in the denominator. And notice in the numerator and the denominator, they both have in common an x squared plus 9. So our final answer is going to be an x plus 3 times an x minus 3 all over 3x. We have one more problem and then we are finished for today. And this problem kind of travels back down memory lane of geometry. So those of you who have been missing geometry, welcome back to it for a slight moment. Problem goes like this. Manufacturers often package products that uses the least amount of material. So we want the least amount of material. One way to measure the efficiency of a package is to analyze the ratio of its surface area to its volume. So what that looks like is you're going to have your surface area divided by volume. So we're going to need to identify what the surface area and volume are of the following 2 shapes. Now please know that the smaller the ratio, the more efficient the packaging. So our goal is to figure out which fraction, which ratio is going to be smaller. So for example 7, Poppy's Popcorn makes a tin to hold flavored popcorn. The tin is a rectangular prism with a square base. The company is designing a new tin with the same base and twice the height of the old tin. The first thing we want to do is we want to identify what the surface area is and the volume is of each tin. So for space purposes, I'm going to draw a line. And we're going to work with the old and the new. So I know it's not labeled on here, but it is on mine. The smaller tin is the old tin, the original tin that they had, and the taller tin is the new tin. So here's the old tin and here's the new tin. The surface area is what we're going to identify first, and then we'll identify our volume. Now remember, surface area is where you add all of the areas, or all of the areas of each side together. So looking at our old tin, we have our top, we have two sides which have a top and a bottom, and their lengths are S and S. And so the area of the top is going to be S squared, and since there are two tops, we're going to make that 2S squared. Plus, we have four sides going around, and the area of each side is going to be H times S. So that's going to be 4 times H times S. And I guess I should probably keep it cursive. All right. Next, we have to identify volume. And remember that volume is length times width times height. And our length is S, our width is S, and our height is H. So that's going to be S times S, which is S squared, times H. So now we need to identify our surface area of the new tin. So our new tin surface area, there are two tops, so we have a top and a bottom, and both lengths are S and S. So for our surface area, we're going to have S times S, and there's two of them, so 2S squared, plus there are four sides, and the length is S, and the width is 2H. So we have S and 2H, and there's four of them. So we're going to multiply 4 times 2H times S. So cleaning that up just a little bit, our surface area is going to be equal to 2S squared plus 4 times 2 is 8HS. So our volume, that's length times width times height. So my length is S, my width is S, my height is 2H. So that's going to be 2S squared H. Cleaning it up a little bit. So now that we know our surface area and our volume for both the old tin and the new tin, we're going to calculate the ratio of the surface area to volume for each tin. So we're looking at the surface area divided by the volume. So I'm going to be looking at the surface area, which is 2S squared plus 4HS divided by my volume, which is S squared H. And I can simplify this because both the 2S squared and the 4HS have in common a 2 and an S. So I'm going to factor out a 2S, and my leftovers is going to be an S plus 4H. I'm sorry, an S plus 2H, excuse me. And I factor out a 2 from a 4, we end up with 2H. Divided by, I'm going to split apart that S squared into an S times H. The S's will cancel out, and my answer for the surface area over volume is going to be equal to 2 times S plus 2H divided by SH. Let's look at the new tin. The new tin, I'm going to look at the surface area over volume. So my surface area, that was 2S squared plus 8HS divided by 2S squared H. So both in the numerator, 2S squared and 8HS both have in common a 2S. Our leftovers is going to be an S plus 4H. Divided by, we have a 2S times H. Just splitting everything apart into prime factors. I'm going to cancel out the 2's and cancel out the S's, and I am left with my surface area over volume is equal to S plus 4H divided by SH. So now we want to figure out, what do the ratios tell us about the efficiencies of the new tin? So we have our old tin is 2 times S plus 2H divided by SH. And our other one is, hold on, I'm not going to put an equal sign. We have S plus 4H divided by SH. So let me clean this up so we can compare, because it looks like they're pretty close to the same. So I'm going to distribute that 2 back in, and I have 2S plus 4H divided by SH. And how it compares to S plus 4H divided by SH is the following. They have every single term in common except for one. This is an S, this is a 2 times S, this is a 1 times S. So which one's bigger? The one that has the 2. Since everything else is the same, which one is bigger? The one that has the bigger numbers. 1 is certainly bigger, or 2 is certainly bigger than 1. So notice that this came from the old tin, and that means that the old tin's ratio is bigger than the new tin. So how do you know which one is more efficient? Well, remember that the smaller the ratio, the more efficient the packaging. So that means that the new tin is more efficient than the old tin. And that's because it has a smaller surface area to volume ratio. And that is the end of today's lesson. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.